Van posting something. All right, we are live. Welcome everybody to the 32nd Data Science Leuven meetup. Again, a virtual one. I guess we're going to be virtual until end of June, depending on how fast the vaccines will be distributed, I guess. But I'm not counting on having any meetups in stick until June. So until then, we welcome you all on YouTube. We have a great show for you today again, with not 3 but 2 speakers, because the third speaker, unfortunately, he got ill yesterday and he had to ask for a rain check, so he'll be back, I think, in January or February. So we are, if you look at the meetup page, there's no new meetups planned yet for January, February, and all the way, but it's coming. So we'll add them to the meetup page. While they're not there yet, let me quickly introduce the 2 speakers that we have with us tonight. One of them is Frank Neve. He's a professor at U Hasselt, the University of Hasselt. And so for those of you who don't know, yes, Hasselt has a university. Some awesome people have studied there. Frank is a professor in computer science, in databases. I can say that, right, Frank? And yes, he's now he's also working a lot with the Data Science Institute that they created in the University of Hasselt. He's also a colleague of Neil Hens, who we had with us in the summer. And Neil is the famous epidemiologist who's trying to help us through this crisis. But so Frank, no pressure. And then we also have with us Caroline. Caroline used to be an academic, but now she switched to the dark side and she became a data scientist in industry. And it will be interesting to see what she has to say about the contrast between the 2 worlds. And Frank, by the way, I didn't mention that, sorry. Frank is going to talk about data profiling and data monitoring from an academic perspective, but trust me, it won't be boring. It's actually super interesting. I know what he's working on. It's super exciting. Caroline works at a consultancy called B12, and you're based in Louvain-la-Neuve, right, Caroline? And you're also building an amazing new headquarters, right? Or is it done yet? You're muted, Caroline. Yeah. You're muted, yeah.
I had to mute myself. That's fine.
Yeah. Sorry, go.
We have really nice new offices, headquarters, which we can't go to yet, but we're impatient to.
Yeah, but soon you will. I expect you're gonna do some kind of grand opening in the next. Yeah. I expect an invitation then.
Not.
All right, cool. With that, let's dive right into the first topic with Frank. For the people watching on YouTube, you can ask your questions here in the comment section, and we'll keep track of them and forward them to Frank. Frank, the floor is yours.
Okay, thank you. You can still hear me?
Yes.
Yes, I'm gonna share my screen. Okay.
Yeah, your screen is shared. Yeah.
Perfect. Okay, thank you, Chris, for allowing me to talk about data profiling and monitoring in this data science meetup. So a little bit about myself, indeed. Chris already told me I'm a computer science professor, and my main interests are indeed data management and data engineering. I'm also a member of the Data Science Institute, of which I guess, like Chris mentioned, Neil Hens is definitely the most famous person at the moment. Now, my research interests, they are in data management, data engineering in general, but more specifically, currently I have 2 topics that I like to work on. The first one is concurrency control and isolation levels, which I will not mention at all. Maybe that's something for a different meeting. But and a second interest of mine is techniques and tools in support of automating data engineering. And the 2 topics of today, data profiling and data monitoring, really fall within this category. So within the allotted time, I will talk about two topics, data profiling and data monitoring, but they're a little bit linked. And I will discuss this topic more on a high level. And I would like to come across, well, what I would like to come across is the types of questions that I'm interested in, and some of the solutions that we are aiming for. And this is, of course, from an academic point of view, but I would also be very interested what industry and practice is doing about this, and if there are maybe some areas where interest could align. Okay, let's start with data profiling, and maybe it's interesting to talk a little bit how I got into data profiling. And for this, I have to look at the MS research that is being done at the University of Hasselt. So I think it's safe to say that Hasselt, apart from COVID-19 research, is also quite famous for his work on MS and the disease multiple sclerosis. And at this point at our university, there is a very large data harmonization initiative going on, right, which is led by Lisbeth Peters, by the way. And within this project, some data preparation and data cleaning needs to be done, and people are working on that. They wrote a very nice Python cleaning script that was handcrafted based on the data at hand. And this cleaning script was very beautiful Python code. I really have nothing bad to say about that. But when I looked at it, I kind of got the impression that part of this cleaning script could be derived automatically just by analyzing the data. So what were some of the things that they were doing in the script? Well, like obvious things like dates are in the wrong format to get to uniform date format, some consistency checks, some outlier detection. They were also looking for ghost patients, for instance, patients that occurred in specific data sets but do not occur in the patient's table, so there is no metadata available, and so they would like to remove those things. So these were things that they were looking at. And so what do you do if you work at a great university like Hasselt University and you have some really talented students there? So what I did was I wrote a bachelor thesis topic, and a very specific person, Lisa Beckers, took up the challenge. And what she did was she actually wrote a data profiling software, a data cleaning project, which is actually available on GitHub. And what she did was her software actually created a report on the key characteristics of the data. And based on these key characteristics, she would generate some potential data cleaning rules. And these rules, of course, have to be vetted. And once they are vetted and also augmented, we would actually, or she would actually, be able to infer large parts of this data cleaning script. And this is also the take that I have on data profiling. For me, data profiling should provide both quantitative and a qualitative description of the data that is actionable. You should be able to do something with it, and data cleaning would be one application, and there can, of course, be other applications. So let's dive a little bit more into data profiling and this quantitative and qualitative description of the data. So I guess most of you, when they think about data profiling and about quantitative information, it's things that you see on the screen right now, right? So if you come across a CSV file and just let's assume that it's relational data, that there are no shenanigans with the limiters and everything is in the correct format, then a data profiler is going to give you some quantitative information like how many rows are there, how many columns are there, what's the size of the table, for instance. And for every specific column, you're looking for what's the name of the column, what's, for instance, the max length of data values occurring in there, something about the fraction of null values, or something about the number of unique values. These are just basic counting properties that you can acquire from this data by doing just one simple pass through this data. So these are examples of quantitative information. Of course, we're also interested in qualitative information, and for this, let's have a look at some examples. Let's say that we're going to dive into one specific column in this patient's table, and this column, the name of this column is clinic entry date. right? So what do you expect from a data profiler? Well, you expect that this data profiler suggests a type for this column, right? And of course, you're not surprised just looking at the name of this column that this will be a date, right? So the profiler should suggest this. It should also suggest a format, right? It can make comparisons between other date columns and see what the majority of the format is and provide some suggestions for transformations. Profiler should also give some distribution, some value distributions, which could give you insight in how the population, or at least not the population, but how, for instance, the dates in this specific column are distributed. For instance, the bulk of the dates are between in the interval 2000-2010. Very few dates are before 2000, and there are some dates after 2010. And of course, once you have a value distribution and you know how many times different values are occurring, you can also detect outliers, depending on the mechanism that you're going to use to detect this. So with respect to a column, this qualitative information should give you guidance for transformations. It should give you some insight in the data and can also be a means for error detection. Let's jump from columns to tables now, right? So let's have a look at what kind of information would be interesting for a data profiler to generate, which relates to the complete table or even all tables which are in the data set. And one example, and this comes directly from the thesis of Lisa, so I'm going to steal some screenshots for her, is, for instance, relationships on dates. Right. So in this patient table, there are 20 columns, and a lot of these columns are date columns. And it is very interesting to look at every pair of columns and try to see if there is a dominating relationship. So for instance, here you see a rule, and the rule actually says that for every tuple, birth date always comes before the clinic entry date, and this rule is valid for 100% of the relation. So this means that for all tuples, it's always the case that birth date comes before clinic entry dates. And if we look at the 5 top rules, then it's not really a surprise that these rules come out of the profiler, because that's definitely, these definitely look like valid rules, right? Birth date, yeah, you can assume that this is usually the first date that is relevant related to a specific person. But if we drill a bit further down in this list, then we see that we also get across some rules that capture relationships between dates which are not valid for 100%. And of course, these are even more interesting. Why are they even more interesting? Because they can actually hint, and they can actually give some errors, right? It could be that this should have been 100%, but it's not, and that the tuples that violate this rule are real errors. And for instance, here, if you look at this one says that the clinic entry date is always comes before the dead date, and it has an accuracy, or it's valid for 99.8% of the tuples. So there is 0.2% where this is wrong, right? And these are definitely tuples that the domain specialist could actually look at, and this would definitely be interested to flag this as something that should be looked at. Of course, when rules have a lower scoring percentage, then it becomes less and less clear whether they are valid, yes or no. So discovering relationships between dates is definitely something that data profiler could do. Another thing is foreign keys detection. And now we come to the ghost patients, right? I remember that in this data cleaning script, they wanted to get rid of patients that do not occur in the patient's table, but they occur in other tables. And of course, this is really an instantiation of violations against foreign keys. So to derive foreign keys, what you do is, well, you just do a comparison of every attribute in one relation with every other attribute in a different relation, and you see whether there are common values. And for instance, if you do this, then you discover that, so here you see the visits table, the MRI table, treatment table, relapses table, and what this rule actually says is that it's always the case, so this rule is valid for 100% of the relation, that if in the visits table, there is a value for the patient ID, then this always occurs also as a value in the patient's table for the patient ID. And this is, of course, the definition of a foreign key, right? This means that there is a foreign key from this attribute to to that attribute. And when this is 100%, it means there are no errors in your data. But the last rule actually indicates that there are some ghost patients, because this means that there is a very small fraction of patients that do occur in the relapses table, but they do not occur in the patients table. So this means that we don't have any meta information about these, and this can be flagged, and then the domain specialist can actually decide what to do with this. So what I want to say here is that taking a step back is that it can be very interesting to try to derive some types of dependencies that hold in the data. And these dependencies should not hold for 100%. They can have an accuracy which is a little bit less, as this can give you a hint that there are some errors in the data. And of course, finding relationships between dates and these foreign keys, they were directly inspired by what was initially in this cleaning script. But if you take a step back and you're thinking about what other kinds of dependencies can we maybe, for instance, try to derive and could maybe reveal some interesting properties of the data. And functional dependencies are, I went a little bit too fast, sorry. So for instance, data relationships, these are instantiations of denial constraints. They are very simple denial constraints, and foreign keys are a very specific form of inclusion dependency. So these are larger classes of dependencies, and it would definitely be interesting to try to derive more general dependencies. And to do this, maybe it's interesting to start with the easiest dependencies that exist, right? And these are functional dependencies. I don't know. Actually, I have no clue who is watching this at the moment, but I don't know if you're familiar with functional dependencies. If you ever studied computer science or if you ever follow the database course, then I guess that with respect to normal forms, that there was definitely a definition of functional dependencies somewhere. But for those who've forgotten all about this, functional dependencies are actually pretty easy. So the syntax of a functional dependency is as follows. You have two sets of attributes, x and y, and then you have x arrow y, and you can read this as like x determines y, right? And the semantics is as follows. So this rule holds in a relation whenever the following holds. Whenever there are two records that agree on all the attributes in x, they should also agree on all the attributes in y. Let's have a look at an example. So this is like the canonical example for a functional dependency. Yeah? So it says that a zip code implies city. So if in a relation there are two tuples, two records with the same zip code, then they should also have the same city. Now, a functional dependency comes in two flavors, right? Either we talk about an exact functional dependency, and then the intention is that the whole relation satisfies a functional dependency. And here, this is an example of this, right? Because all the tuples that have the value 3,500, they also have the value of Hasselt for the city attribute. So this functional dependency this relation satisfies this functional dependency completely. There are no errors, there are no violations. If you're thinking about data cleaning, then you're not necessarily always thinking about functional dependencies that hold uniformly over the complete data, but you're also a bit interested in functional dependencies that hold partially over your data, because they can indicate errors in the data. And we call a functional dependency partial if a large percentage of a relation satisfies the functional dependency, or if there are just a small number of violations. You can define this more formally, but that's the main idea. So in this data cleaning exercise, one of the ideas was let's derive all partial functional dependencies, and let's see if something interesting comes up. And to our great disappointment, this didn't really turn out to be so enlightening. One of the problems that we discovered was that there are far too many high-scoring partial functional dependencies. For this patients table, which contains 20 attributes, I think we found something like 350 partial functional dependencies with a very high accuracy, right? So with only a very small number of violations. And of course, 350 dependencies, well, you cannot really show this to like a domain specialist, right? And just ask them, can you sort this out, please? tell us which ones are interesting and which ones are not interesting. And to give you a little bit of a flavor of the difficulty of this, like why is this hard to do? Why is it difficult to see whether functional dependency is relevant, yes or no? I'm going to show you some high-scoring functional dependencies, and we can dive into whether they are relevant or not. So, for instance, this is more like a canonical functional dependency, right? It says that birth city implies birth country. And that seems like a valid functional dependency, right? It means that if there are two persons that are born in the same city, they should also be born in the same country. Yes, that seems rather obvious. And the accuracy of this rule was not 100%, but 99%. But still, this is a candidate for like a universal rule, right? Violations against this rule are probably errors. Maybe typos, could be real errors. A different functional dependency that came across in this analysis with this patients table is the following. So this one says that birth city implies country. Now, what's the difference between this functional dependency and that functional dependency? Well, it looks the same, but it's not the same, right? This talks about the birth country, and this talks about the country of residence. Of course, there's no law against people moving out of their country, right? You can definitely move to a different country. So it should not be the case that when two people are born in the same city, that they also currently are living in the same country. Nevertheless, also this rule has a very high accuracy, also 99%. And this is definitely not a candidate for data cleaning because it doesn't correspond to what we know about the world. Still, this rule could be interesting because it could maybe provide some insight into the distribution of the data. For instance, it tells that most people in the data set actually stay put. They do not move to a different country. Not that this is relevant for MS, but nevertheless, it's an observation that two very similar rules with the same level of accuracy, where one is definitely a universal rule and the other one is definitely not a universal rule. I want to show you some other rules with a very high accuracy. So very high accuracy means that there are almost no violations against these rules. So they get a very high score. So initially we thought, oh, well, they could be very interesting. But with a closer examination, these rules actually don't look so interesting anymore. So what's happening here? What are we looking at? So all these rules are the same, right? So these are all functional dependencies. And on the right-hand side, you have one attribute. And this attribute is called det. It's a Boolean, so it's either true or false, and it indicates whether a person is deceased, yes or no, whether he or she died, yes or no. And it would be a little bit strange that, for instance, the birth city, like the city where you are born, would functionally determine whether you are dead, yes or no, right? So that observation already shows that something fishy is going on here. So what's the reason that these functional dependencies get such a high accuracy? Well, the reason is that the data is skewed. It's skewed a lot in the sense that most people in the data set are still alive. So for most people, the dead attribute is false. There are only a very few patients that have deceased and where this that attribute is true. And if you have such an imbalance between values which can occur as a value of a specific attribute, you can get this very strange accuracy ratings. It's very difficult to detect this automatically. So to do this, we need measures for interestingness of functional dependencies. And the measure that I used in the previous slide was based on the number of violations. That turns out is not always such a very good measure. So it seems like a good measure in the context of data cleaning, because if there are not a lot of violations, then maybe these violations, the small number of violations, are errors, and we need to do something with this. But on the other hand, it's very easy to trick this measure. Now, there are other measures. For instance, you can have like a probabilistic interpretation of functional dependency, or you can also have an interpretation of functional dependency which is based on entropy. And at the moment, there is another student, so we have a lot of good students at Hasselt University. We are looking at interesting measures and whether we can actually sort functional dependencies according to interestingness in such a way that actually corresponds to interestingness with respect to a real data set. And something else that we discovered is that most work in academia, so I'm from academia, has been devoted to discovery algorithms. There are a lot of discovery algorithms for all kinds of dependencies, functional dependencies, all other kinds of dependencies. And there has been no work on ranking of functional dependencies. And this is a real pity, because I think there is a lot of potential for these dependencies to be used to explain what's happening in data sets, but there is still quite a bit of work to do. At the moment, it's really unclear what good measures are. And this is just the initial step, because functional dependencies are the most simple form of dependencies. There are a lot of extensions of functional dependencies or more involved dependencies that capture even more interesting information. So for people who are interested in this, there's a very interesting book written by Ihab Ilyas and Xu Xu about data cleaning, at least the academic equivalent of this, where they talk about all kinds of dependencies. And I think there is a lot of untapped potential which exists at this point, that we have not, in academics, we did not look close enough to how to actually use dependencies to talk about hidden structure in data sets. And it's definitely one of my interests to look at this. But for this, you need access to real data sets and also to domain experts. And I will come back to this at the end of my presentation. So data profiling talks about finding characteristics in data sets and then putting them to use. That's my view on data profiling, and I will come back to this at the end of the presentation. Good. So a second topic. So if you thought that, well, this is a new topic, so if you fell asleep or thought was maybe a little bit boring, this is something completely different, although it is a little bit related to the previous one. It's also a topic that I'm extremely interested in, and it's about automating data monitoring. So this is one step beyond data profiling. And this is work, so I'm going to explain work that has been done by one of my master thesis students, Peter Olaerts. He did this last year for his master thesis. And Chris Peters was actually the external supervisor for this. Chris, thank you very much for that. And at the moment, Niels Billois is working further on this topic. What is this? Automating data monitoring. I think the best way to explain this is by means of an example. And what you see here, and as an example, I'm going to take the Belgian Railroad, right? So the NNBS. So NNBS had lots of trains which are riding around through Belgium, and the NNBS is logging a lot of information with respect to this train. So I do realize now that this is actually in Dutch, so my apologies for this. But what you're looking at is that it's a table, and this is the date of, let's say, today, right, of a specific day. Then every train has a specific number, and a train drives a certain route, For instance, this one rides from Leuven to Hasselt, and along this route, the train stops from time to time at a station. For instance, here in Wezenmaal, it stopped at a specific time point, and then it departed again at a specific time point. And all these events are logged in a big table. And at the end of the day, all this information is pushed into a data lake, and there it joins, this data set joins with all the other data sets of all the other days, and you get basically a table for every day. And one question that I'm interested in, or that we would like to address, is what is different today in relation to the past? So let's say that this is a data set of today. It's just arrived, and I want to know what's different from before, right? So what's different in relation to the information that is in this historical data sets? And to give this a little bit more focus, we are interested in differences in data distributions. And I'm going to give you some examples of things that we are interested in. For instance, possible answers are the following. For instance, there is a train. the train with number 567, it's just an arbitrary number. Well, this train should have stopped 9 times, but actually today it stopped 10 times. So when looking at historical information, we see that usually it stops it stops 9 times, but today it stopped 10 times. Another example is, well, on a very specific route, maybe from Genk to Blankenberge, there are 10 trains a day that run this route, but today there were only 8, right? So there is a difference between distribution, between statistics. So basically, these are like aggregations over the data, and there are differences between these aggregations between the current day and what was expected, the number that we expected to get. So how can we solve this, right? So how can we detect such discrepancies? Well, if you know what you're looking for, right? If you know what you're looking for, then you can just make this into a SQL query, right? For instance, this query, what it's going to do is it's going to count the number of distinct trains that ran over the route Genk to Blankenberge. So this is the example of the previous slide. So if I run this on the data set of a specific day, let's say today I get the number 8, and if I run the same query over all other data sets in a specific window, so the window here is maybe like 7 days, I also, for every day, I get a number. And then it seems at least that the expected answer should be 10, because that's the one that occurs the most. And that could be, we could conclude from this that, yeah, indeed, maybe there is an outlier today for this specific route, because the expected value was 10 and the one that we got was 8. So if you know what we are looking for, it's just a SQL query. But of course, my approach is, can we automate this? Right? Can we find interesting queries automatically? So and here is the relationship with the previous topic. In the previous topic with data profiling, you're interested in, can we find dependencies that structurally explain the data? Here, can we find interesting queries that we would like to monitor? Because if that's possible, then we could work up to an automated dashboard, right? We could just run a system, and that would explain to us every day what discrepancies were found in today's data set. So if you want to build up towards such an automated dashboard, then of course, well, first we need to determine what are interesting queries to monitor. And I will explain a possible way to do this in the next slide. And once we have done this, then of course we can use a deployment phase, and we could just run all these monitoring queries, compare it with historical data, and if there are outliers, we can report that to the user and maybe get some feedback. So the main thing that we need to focus on is, how do we determine which queries we want to ask, right? And this leads to the discovery of monitoring queries. So these are the queries that potentially will give, hopefully, interesting results. So let's look back at this example query. So this example query gives you the number of distinct trains that ran over a specific route. But this query already refers to one specific route. And I think that this is a bit too specific, right? We are interested in all kinds of routes. We don't want to restrict attention to one specific route. Actually, we're interested over a whole bunch of possible routes. And we can get this behavior by just eliminating this selection with this where clause here. So if you look at this query is going to compute for every possible route, and I think in the data set there are something like 160 routes. For every different route, it's going to compute the number of trains that ran over this. And this query, if you run it over the different data sets, then basically what you get is a sequence of key value pairs. So this query, if you run it over the data set, for instance, of, let's say, the 28th of November, then for the route Genk to Blankenberge, it will give a number, let's say 8. For a different route, maybe Hasselt to Antwerp, it will say 6. For another route, maybe Hasselt to Liège, it will say 6. And if you do this for specific time points, you actually get a number of key value pairs. For every route Dus Genk to Blankenberge is a different route. You get a sequence of numbers. For every other route, you also get a sequence of numbers. And now what you need is, how do you determine whether there are outliers against such a route? And you can do this as follows. Well, you need at least some mechanism to determine outliers. And what we used is the median absolute deviation. It's not so important exactly what this is. And you can also use other mechanisms to detect outliers. But you need some mechanism to detect an outlier. And maybe, for instance, for this route, there is one outlier. Right? So the majority of values is 10. So this one is an outlier. Maybe I can actually do that like this. Here, all values are 6, so there are 0 outliers. So here there is one outlier, this one. Here there are no outliers. And on this route, there is also one outlier, this one. So we have 1. So in which type of queries are we interested? Could this be potentially an interesting query? Well, we are definitely interested in stable queries, right? Because the query that we want to monitor, it has to produce a result, like a count of something, and then we need to check with respect to the historical data whether this number is a deviation, yes or no. So one thing that we definitely want as a requirement for a potentially interesting query is a stability score, right? We are interested in queries of this form that do not have too many outliers if you run it over all historical data or a part of the historical data. And for instance, you could define the stability score of a query as follows. You look at the fraction of outliers over all key value pairs. And here you had 2 outliers. This one was an outlier and that one was an outlier. And you have 12 values, right? So the stability score is 1 minus the fraction of outliers. So 2 out of 12 are an outlier, which is 5 out of 6, which is 83%. Of course, this is just a snapshot. You only have 3 routes here. Normally, you have 160 routes and you have many more data points. But the basic idea here is that you're interested in those queries which give like a stable result. You don't have too many outliers. From time to time you have one, but not all the time, so to speak, because then you would get like a random result. So coming back to the initial query. So what kind of queries do we want to monitor? Well, we're going to focus on specific queries of a specific structure. We're interested in discrepancies between data distributions, like statistics. So we are going to compute aggregate functions, and we are only interested in those queries that have a high stability score. And we developed some algorithms to ensure that we only derive interesting queries and queries that have a high stability score. So this fits into the idea of working towards an automated dashboard. The first step is discovering monitoring queries, and we're experimenting with all kinds of expressive queries. And we implemented this system on top of Postgres, which is a very robust database system. And actually, it's very capable of dealing with these monitoring queries. We are not running into problems yet. Of course, when we are going to work with larger data sets, then maybe there is some potential for query optimization, like incremental query optimization or multi-query optimization. But I'm going to skip the last thing. Okay, summary. I'm really interested in problems that work towards automating data engineering. And the thing to remember from this talk is that is data profiling and data monitoring. In data profiling, I really think that the important thing is to discover meaningful dependencies in data. And that's a problem that has not been solved yet. Discovering dependencies, there are lots of algorithms for them, but discovering meaningful dependencies, that's really hard. There are no good measures at the moment, and I think we need to look at this in more depth. Applications for this are, well, you're going to increase the understanding of the structure of the data. This can be applied to data cleaning or also to generate mock data, because of course, if you know much better what the meaningful dependencies or the structural relations in your data are, and then you want to generate more data that adheres to the same structure, then of course you really need to know what these structural relationships are. And at the moment, we do have access to some medical data, like this MS data and some other data in the medical realm, but I'm really looking for other domains. So if there are people in the audience who are saying, oh, I have some data sets lying around and this sounds really interesting, we definitely want to know more about our data, or we definitely are interested in deriving automatically structural relationships, then I would definitely be interesting to talk about that. So this is definitely a call for data and domain experts, and I hope that this could be an interesting venue for this. On the other hand, data monitoring is also about automating. You would like to derive interesting relationships in your data, and the focus on in this work is in exposing discrepancies in data distributions over batches of relational data. The example that I gave was with respect to event data in the transport domain, but it doesn't really have to be restricted to such a domain. You can also do this, for instance, over hospital data. There you don't really have separated events, but you also have like patients that stay in the hospital, that leave the hospital again, and you're really interested in questions about, can you say something about the average time a patient stays with respect to a certain treatment in the hospital? Yes and no. Are there possible discrepancies? So also in other domains, I think this can be useful. And the applications for this work are automatic dashboarding or data observability, where you really would like to monitor and would like to see if there are some unexpected behavior. So also for this work, if you think, that sounds really related to questions that we are having, or that you work in a specific domain where this approach could be interesting, I would be really interested to hear about this. Okay, thank you. This was everything I wanted to say.
Thank you, Frank. Thank you very much. I really liked it. But then again, yeah, I'm a data engineer, so well, we talked about this before, but I like the fact a lot that the topics that you work on, like they're very relevant day to day. Like I see we're struggling with each of them every day. So I also think that in your last slide where you mentioned like data observability and automated monitoring and all of that, like each of those, I think we in the industry could definitely benefit from a lot more academic research. And I like the fact that it's not just a pure AI algorithm that you're looking at, but you're actually looking at the data engineering side of stuff from an academic point of view. So I'm looking forward to much more results coming out of your group. And with that, I'll maybe switch to questions, because there are a few questions.
Sure.
Edmond Sesse, sorry if I mispronounce your name, but I'll read the question. So, hey Frank, hi, question for Prof. Neve, I should say. Has his team tried machine learning or deep learning to automatically detect functional dependencies and doing profiling in general, apart from using only rule-based approaches?
Myself, no. I definitely didn't try any machine learning or deep learning techniques for this. And actually, I'm also not aware that there is some research on this. If there is, I would definitely be interested in this. For me, what is very important is the end result, right? You would like to get some insight in the data, so you would like to get some dependency. I don't want a DL algorithm that says here is an error, there is an error. I really want to learn about the structure of the data. But of course, if that can be achieved by applying machine learning or DL techniques, then that would definitely be interesting. But also here, even though that approach could work, I think you still need measures to determine, or at least a deeper understanding about what kind of dependencies are actually interesting in which situation. And I'm not sure that DL itself is going to help in this, unless you have a really large data set, like label data set, where it says like this is interesting, this is not interesting, then that might be something different. But if you are aware of approaches for deep learning approaches for functional dependency or auto dependency discovery, I would really be interested in that.
All right, cool, thank you. Then the next question is from Istvan. He says, how do you avoid obvious results, such as for the NMBS data? For instance, a particular day was a bank holiday.
Oh, that's a really great question, because I didn't address this because I wanted to keep it short. I have no clue how long I spoke. I said to Chris it's going to be very short, but I think it was very long. But then again,
we have time. We have time.
I skipped some things, but this is a really important question, because definitely with the NMBS, it doesn't make any sense if your new data is a Saturday to compare it with what happened on a Friday, because we all know that the schedule on a Saturday is not the same as on a Friday, and also not on a bank holiday, and also not on the summer holiday at all. So this approach actually assumes that there is some kind of grouping already done by someone. So either someone has told you, look, Saturdays are a group, Sundays are a group, weekdays are a group. If that's the case, then you're set and you can go. If not, then you can try some different clustering approaches, and we actually did this, right? The idea is, can you actually cluster? Can you actually detect yourself which days are belonging together? And it turns out, yes, you can actually do that. And you can also use these monitoring queries for this, because this monitoring query, on the one hand, it's actually a mapping for a given query and a given relation. It gives you a mapping from that relation to a set of key value pairs. And that's like a vectorization of the data. And once you have a vectorization of the data, you can use arbitrary clustering algorithms like k-means clustering. Actually, Peter in his thesis investigated this, and it does seem to work, at least for this NMBS data. I don't know if it works in general. Like, for instance, if you have different granularity. For the NMBS, it's really simple. Right? It's a day. That's a unit of time. But for instance, like in an airport, or if you look at a hospital, it's less clear what the granularity are. And I think there are still some challenges there. But I definitely did not talk about it. So it's very perceptive of you.
All right, cool. Next one, again from Edmund. He says, hey, can you foresee use of data profiling and data engineering to detect data drift?
Oh, yes. Yeah, so I don't know what data drift is. So Chris will explain this to me.
Putting me on the spot here. No, what I think, but Edmund, correct me if I'm wrong, but how I see data drift is that your data slowly changes over time. So let's say your arrival, well, I don't know if arrival time is a good measure, but your average transaction value is 52 euros and tomorrow it's 53 euros and 54, and all of a sudden, like, there's something drifting, but you don't see the small changes, but over time you go like, no, something's going wrong here. That's data drift.
Yeah. Okay. Yeah. So I guess, for both topics, I guess you're deriving either structural information or some interesting monitoring queries that can change over time, right? You can keep on doing this. So definitely with the data monitoring, I kind of presented this like you do it once, right? And then all these monitoring queries are fixed in stone and you just never going to change them anymore. Of course, that's not very realistic. I think you could think about approaches where these can be changed, right? And where you do like a retraining or relearning or rediscovery from time to time. So in that aspect, I think you can take data drift into account to detect data drift, of course. Then one way to do that would be in data profiling, do it on one data set, and then on the same data set, I don't know, a couple of time instances later, and see whether there are discrepancies between them. So maybe that could be that could also be a way to deal with that. But of course, that's just my guess. I don't really familiar with the real problem that data.
All right, cool. Then there was a remark from Bob de Schutter. He says, actually, the Monte Carlo platform claims they use ML techniques to learn your data and discover reliability issues. But I think, if I know the platform a little bit, I think they are mainly focused on your right side, so on data monitoring, not so much on the functional dependency side. Well, that's how I understand the platform.
I would be extremely happy if someone would come now and say everything that you talked about is solved. I would be extremely happy about this, because it's a little bit of a frustration also on my part that there is so much research being done in my area, and when I was faced with a real data cleaning issue, like for this MS data, I could not find any tools to do that. I mean, all this research and no tools. I actually had to, well, not me, Lisa had to do it herself, because there was just nothing off the shelf that we could use. And so I'm a little bit frustrated that there is not more available. So if now someone says, well, actually there is, I couldn't be more happier. But I'll definitely look at that platform and see what it does.
Well, and for academics, I guess it's a lot of opportunity to do research. For entrepreneurs or startups, I'm pretty sure there's a lot of opportunity to launch a new startup idea here and scale tremendously, because from industry side, I can say that all of the things you talked about are actual problems, right? So we're also waiting for someone to solve them.
I must confess that in my research area, there are quite a number of startups recently. So professors, researchers who have been doing data cleaning, actually quite a few of them make startups, like Trifacta is one of them, and there are some others. I'm a little bit ashamed that I forgot the names now. But I think exciting things are happening, but I also think that the field is still wide open.
Yeah, the other one is Stammer, maybe.
Yes, indeed.
All right, so one last question. Well, I gave you a lot more time because we have only 2 speakers instead of 3, but now it's kind of time to move on. But we'll do the very last question from Peter van Rose. He says, is a stability score always a stable over time matter, or could that be on another dimension, like stable over different customers?
So let's see, stable over time.
I think.
Okay, yeah. No. I see what you mean. Absolutely. So at the moment, it's stable over time, right? But this is also why I would be really interested if I could find more people with actual data and actual problems, because I really prefer to work from problem driven. Like this is the thing that we would like to monitor, and then I would like to see, can we derive this kind of things automatically and then actually give you more than you asked for. And this is why with the NNDS data, it makes a lot of sense to do this stable over time. But of course, stable over a specific subset of the data, that's also possible to do that. You can either change your query to take this into account, or you do your batching differently, right? No one says that you have to take the complete data sets into account, but you can also envision batches that only contain a subset of the data, and that would open up possibilities to do that with respect to a specific customer. Yes.
All right, cool. With that, I see Niels is posting some answers as well. You're a PhD student, Frank.
I love that.
Well, with that, we're gonna switch. Frank, thank you so much for giving your presentation. It was super interesting, and good luck with your research.
Okay. Thank you.
All right, Caroline. With that, I just added you to the stream. Sorry. Yeah, we're going to switch topics. I'll also make you able to share your screen if that's okay with you.
Yes.
Yeah, all right. Yeah, here's your screen. All right, Caroline, the floor is yours.
Okay. Thank you. Thank you very much for the opportunity to talk tonight. I'm going to try, because I think it's not an easy task that you actually gave me. To talk about data science and maybe more generally data analytics in the industry and in the academic world, and a bit see what's actually different and where we can meet and where we can help each other. I'm gonna come out and I'm gonna move so it's outside the presentation. Sorry. So to give you some context, this is really not a technical talk at all, which actually, when we talked about what I would talk about, I was quite excited about this topic, like industry and the academic world. And I mean, it was an occasion to self-reflect, maybe also a little bit. But I must admit that making the presentation, I realized that for people like me, giving this type of presentation, which is non-technical and where I can rely on what I know very well, the equation, the plots, the definition, even lemmas, it's actually more difficult. And this is maybe one of the first difference between academia and the private sector. I think in academia, we tend to give mainly technical talks and maybe less, you know, opinion or reflection talks about the fields. I also really wanted to give a full disclaimer. What I'm gonna say today is really based on my personal experience, which is being shaped, of course, by me and maybe what I'm sensible to, what I like, what attracts me in research and in my daily work. But also the university and the departments I've worked for, and the companies I worked for, and of course the people I work with. Maybe some people experience some other things, and I would be very welcome to hear your comments about that after or during my talk. Don't hesitate. So the goal of this talk is to kind of launch a discussion and a reflection, and it's certainly not intended to be the ground truth or to be an exhaustive comparison of industry or the private sector and the academic world. So some background about me, which, you know, I don't really like to do, but I think as, you know, I'm going to talk about my experience, it's good to know that you know what I've done. I started a long time ago. Don't add up the years because it's too much. At the Institute for Theoretical Physics at the KU Leuven as a PhD student. I did really many research, and it was not even really data driven, or not at all. It was really like pen and pencil deriving of some proof of lemmas and that kind of thing. And I did some teaching back then too. And then we moved to Hamburg, where I worked for 4 years for it's a very long name, International Association for the Evaluation of Educational Achievement. So it's an NGO who organize international assessments or surveys about the level of pupils and students in secondary schools and in university, and makes it comparable across countries. I worked there in the sampling unit. And so the job was very operational. So we talked to countries to understand the school system, and we actually drew samples of schools and of students in school to participate in the survey. And after the survey, we kind of calculated weights, as we call it, so to arrange for bias for school who had refused to participate, for students who were sick, to make sure it was comparable. And we also calculated the sampling variance. So yeah, we still did a little bit of research there, but it was really very operational work. And then we moved to Switzerland. Sorry, when I worked at the University of Lausanne as a postdoc, and actually was detached at the Swiss Center of Expertise in the Social Science as a methodologist in surveys. And there I did a lot of research, but I also kept on doing more operational work. I was editor-in-chief of a journal there. We talk about the strategy. We developed the strategy of the methodology for FORCE and those kind of things. So it was more balance between research and operational. Then I came back to Belgium and I worked 5 years at the sociology department of the KU Leuven, where I actually redid a PhD. And I also did more research, but also still operational work for the European Social Survey. So we worked a lot of deliverables or report, as we call it, on data quality of the result of the European Social Survey. And 2 years ago, I completely quit, although the IEA was a bit outside of academia, but I quit the academic world to come and work at B12, which is based in Louvain-la-Neuve. It's a consulting company who does software development and data science. I work there as a data scientist, and we do really mainly operational work there. So this is about me. I've done many different things, but as you say, I didn't really do academic work in machine learning or data science. And I also didn't work for Google or Facebook. So, you know, I don't have the full spec of all those possibilities in the two worlds. So one of the first problem, if we take how we work in academia and even in the private sector, kind of chronologically, is how do we choose what to work on? How do the research question problems to solve pop up? Well, in academia, at least in my experience, it was like really known open problems in the field of research, or a follow-up of a previous paper, either of a colleague or of my PhD supervisor or my own paper. We had thought, oh, this would be a good idea, but it's a bit out of scope, so we'll keep on, digging in that direction in a further paper. Problematic will rise up from conversation with colleagues or fellow researcher. Also sometimes because you talk about two ideas that you have and they come together and it pops up a new research question. But I think all the essence is that the goal in academia is to advance scientific knowledge and to publish about it. The emphasis is a lot on publishing in general. Well, in the private sectors, and at least when you do consulting, the challenges often comes from clients who want to, if you do data science, optimize their products. They want to optimize their process. They want support to innovate in the companies, or it can be. And when I say from clients, it can also be in a bigger company where you work in the data science department and you have other department who come and ask you to solve problems for them. It can also be internally to develop tools that are useful for the company. But the bigger difference is that the goal is mainly the optimization of the company cost benefits. You want to optimize your client satisfaction and you want your business or your company to develop and to grow. You may be slightly less interested in, advancing the scientific knowledge when you work in the private sector, although I think we're all interested in advancing scientific knowledge. I went back instead of forward. I think one thing which is very common is, you get the problematic, either it comes from a client or it comes from a conversation you had with your colleague during coffee at university. But honestly, the way you tackle the problem is always analytically, I think, at least if you work in a science field. So you decompose the problem, you analyze it, and then you build your solution. Although saying that, I think the emphasis is maybe slightly different. I think in academia, you may be gonna try to go for the elegance and the real innovation and prove that you advance the scientific knowledge in your solution. Whilst in the private sector, it's way more important to be very efficient, to have something which is very robust. I mean, you maybe care less about the 1% accuracy at the end or the 0.5 if you have a more robust solution. Although if you want to stay ahead of your game, you still have to innovate. It's really key to be, to keep a competitive advantage. And I want to emphasize that I say emphasis. So I'm not saying that, academia is not robust or not efficient, or that, the private sector cannot be innovative. I think it's just really a question of where the emphasis lies and what you concentrate on. And then you have developed your solution, and of course you have to deliver it. And I think that there is where we also really separate from each other. So in the academic world, and I think publication is really key. You have to publish for your work to be seen in peer-reviewed journals. Depending on the field, there's really a few journals where it's very good to publish because they recognize as being the best journals. You can also present at conferences, and I think the content of what you do is more important than the style or the form that you give it. So the content will prevails in academia. In the private sector, what you deliver needs to be a usable tool for your clients. And so depending on the situation, it could be an application, a Python or R model. It also maybe just a report or a POC. It has to be something usable for your client who who kind of came to you and say, can you do this for me? So in the private sector, the form is as important as the content, the form, the style, the packaging of your solution. And to come back on that, it's because what we have in the private sector, which is very different than in academia, is users. I mean, in academia, your work is targeting towards your colleagues, your peers, fellow researcher, people working in the same area. We have very similar knowledge to you, so they're more able to understand. You don't have to package it to sell it to them. They know why your research question is important, and they're really able to understand your solution. In the private sector, the solution you build may be for non-computer data scientists, for non-computer or data scientist experts. First of all, the end user may be coming from all different kinds of backgrounds, and it has to be accessible to all of them. So your solution needs to be very user-friendly. And that's an emphasis which is more important in the private sector, I believe. Another big area that I've certainly discovered into last year is all the operational and the productization of the data science solution and all the problems that you see of data drift. So you have an algorithm who works well with trained on data that you collected months ago. Will that still be good in 2 years? So also the automatization of the retraining, all those things are really a key task, which I think are very specific of the private sector. I'm not saying that academia doesn't focus on it, but I think the focus is less there for them than it is for us. So in French, we say tout travail mérite salaire. So of course, where does the money come? So research in the academic world is mainly funded through grants and public funding, whilst the work in the private sector is mainly funded by private companies, clients. And I think a lot, and I'm not saying that academia is not constrained to budget, although I never felt the budget constraint as I was in academia, but also less to time constraint. I think there's less constraint, even if constraints are there. And then I thought a little bit of what's different now in my daily work in the private sector as a data scientist than it was when I was a researcher in academia. And funnily, I don't know, maybe not funnily, I find that I work way more in teams. And when I showed my presentation to a few people, and some of them asked me, do you have any idea why you find teamwork more present than when you were in academia, where I certainly felt more isolated in my research. And it's probably structural, right? A private sector is very much organized in units and teams and those kind of things, but it's maybe something we can talk about when I'm finished. I think there's way more diversity in the projects. When I look what we do in B12, we work in different domains, we work with different types of data, we have different types of solutions, so there's certainly more diversity, which is very nice and very how to say, motivating. There's certainly also more diversity in daily activity. So there's still the research or the analytic work coming up with a solution for the client. There's also what I would call project management at 2 levels. There's the whole relation with the clients. So understanding what their needs are, decomposing the problem with them to understand what they really need, because sometimes we realize when we talk with clients that they ask for something, but it's maybe not what they ask that they really want. Explaining the solution, because they may be, non-technical expert, as I said before. And there's a big work to be done in managing expectation, because when you offer a data science or artificial intelligence project, some solution to somebody, they sometimes think that, it's going to solve every problem. So that's the relation with the client, and also your team, managing the deadline, managing the budget, seeing that everybody is happy, those kind of things, and all the kind of business development. And that's not only finding new clients, but it's also, promoting data science in industry and those kinds of things. Which all of that I enjoy very much. And I also like the diversity of the work would kind of give you time to sometimes step back from, your research or your analytical work. What I maybe miss a little bit is the freedom to chase, around the fun analytical problem that you discover because they're out of scope, and if they're out of scope, there's no budget for it. But maybe that's because I'm not the only one defining what fun means, ? Also maybe a good subject to chat about after this. And then before we kind of wrap up, I'm sure you all read the journal, and you all read, I'm not sure how to pronounce her name, about Timnit Gebru and Google. So Timnit Gebru is one of the Google stars in AI ethics and research, who was fired last week for an email that she was criticizing Google's behavior towards employees from minority background. A few days before she was fired, she did tweet, with the amount of censorship and intimidation that goes on towards people in specific groups, how does anyone trust any research in this area can take place? Of course, she works for Google. So I was wondering if university were places or would be more open than Google or any private company to critics that are turned towards them. And whether science community would be more open to researcher publicly criticizing theory subjects to large consensus than companies would. And if I was also wondering if university would be more accepting of a criticism towards research that they openly, sorry, my sentence is not right, but if they would accept to be straight away criticize their own work, if they would mind that their own people criticize what they've produced as work before. I'm not going to answer them. I think they're very good questions. And I think university as private company should be able to self-criticize and self-accept critics towards them. But I ask a question, and the question is, where do we meet? And we already meet, and probably way more than we did a few years back. So solution to tools developing the freedom of the research at universities, I already used daily by companies like ours. Think about Skylearn, everything was done around deep learning, or maybe even the tools that Frank was talking about the development of the tools that Frank was talking about. At the other end, I think the private sector generates challenges which can be inspiring for the academic world. So we can talk of all the algorithms around the recommendation tools like Google's, the preventive maintenance, the anomaly detection, all those kind of things. I think we can certainly collaborate, as shown by the many programs where university collaborate with private companies for things like PhD programs or the student internship. There's also all the problem, I think, not always need to be technical. There's also the old ethical AI and ethics and AI and law problems. So I'm wrapping up. So in my view, I think the big thing we have in common and the common ground to talk to each other is the way we tackle the problem. So we all have an analytical background and we work analytically. Even though the goal of the work is always different. One is, academia is for scientific progress. Whilst, if you're in a business, what you want is business growth. The constraint, I think, different also. I think the budget and the time constraint are way more present in the private sector, which is not always a bad thing. Maybe sometimes it helps you to be more focused. The users are very different, and so is the end product of your work. I think the society really needs both data science in university and in the private sector to go forward from where we are. and we certainly can collaborate and support each other. And I wanted to ask you some question to try to encourage you to post some comments. I was wondering if I forgot something about the difference between academia and the private sector, which jumps to your head. If I said something that you completely disagree with, and then when we talk, do you think that the university are more open-minded towards self-criticism? And I think this was me, so I'm going to escape and see if I see you again. I do see you again.
Yeah. Thank you, Caroline. Thank you for your presentation. It was super interesting. In the meantime, there are a few questions on the right on the chat. So let's go through them. So Peter, it's not a question, just a confirmation. I think said, hey, very good summary of the important differences between academia and the private sector. I have similar experience and I recognize all of the points you have made, Caroline. So you're not the only one who looks at it this way, so that's good. Then there's this weird dude asking a question, Paul Smith, but we're going to skip him for a while. And then Edmund said, well, we'll come back to you, Paul, don't worry. Edmund says, hi, Caroline. In your experience, how long does it take for concrete research findings to enter mainstream products? Ooh, that's a tough question.
It's a very, very tough question. I mean, I'm not going to answer it. Let's be clear. I'm gonna give some bits of. So I first it depends on mainstream products, and as I said, we need something to be robust to be able to put it in production. So I think it has to show first that it's not that you're not going to publish something and we're going to use it the day after tomorrow. Maybe we'll wait a month or so. But it depends how and where. It's a very difficult question to answer. I mean, we really try to always use the more up-to-date technology, of course, but it has, it depends where it comes from and whether it has done its proof. We need robustness also. We can't sell to a client something which hasn't been shown to be robust yet.
Yeah, and I can add to that, but just from my experience, but maybe also a bit related to what Frank was saying, there's actually a lot of research that would be valuable in the industry, which is never actually industrialized. I definitely don't claim to know anything about academia, don't get me wrong, but I attended a few academic conferences like the VLDB, the Very Large Database Conference, and that is like, I think, I went to one in 2013, and I saw concepts there that today there's still not present in any commercial system that I know. So I think I think there's actually a lot of, waste or opportunity, depending on how you look at it, between cool things that they're doing in academia and then industrializing them. And I can say from my point of view, but I don't know if it's fair, but and maybe that's also what you said, Caroline, that I want to be sure that something works before I actually use it in day-to-day projects, because in the industry you don't have the luxury of, I'm going to spend the next 3 months investigating if this tool is right, and then I'm going to write a paper about it if it's not. It's like in industry it's go, right? So yeah. And there's actually a huge gap between the two worlds, in my opinion. Yeah.
Between theory, I mean, going from theory to actually production, it's not so easy.
Indeed. And then Luc Wuitens asks, how much cooperation is there today between... my thing jumped. Sorry. Today between private and academic in your perspective, exchange of knowledge, etc.
I think it's something people probably from the academia have been working really hard on. So this, I mean, we get we have a lot of internship from PhD students who come and work at ours, and I think this, I know with Paul, there's also people who work there. So I think people are working to, both from the private sector and academia, are working to close the gap at the minute. And I certainly have the feeling it happens more and more.
Okay, cool. Then Istvan has a remark. He says, remark for Caroline, I agree that productization is a key difference between the private sector and academia, although in engineering faculties this might be different. Yeah, okay, and then the next question is, hi Caroline, thanks for the presentation. I think it's important in academia, computer science, to look at the real world scenarios and applications, so it's easier to adopt, implement as well. Something Prof. Neve and I are aiming for, so yeah. It's good. It's another confirmation of what you said. Maybe let's quickly jump back to the question that Paul asked earlier, because it's I kind of skipped him. Just for the others here, Paul is the husband of Caroline, right? So it's like, yeah, no, he can't ask the first question. But so Paul asks, what do you think is a good main thing that academia could learn from the private sector and vice versa?
Oh, that's a question.
Thanks, Paul.
Thank you. Yeah, we'll talk about it tonight. So from my point of view, what helped me in the private sector that I definitely learn a lot in academia, it's critical mind, and not thinking like this doesn't look right, or I don't mind. It's really that analytic decomposition and be very critical. And I think a long time in academia, I mean, I'm not saying other people don't have it, but it's something you develop in particular when you stay a long time in academia. The other way around is more difficult because I went that way, right? I went from academia to the private sector and not really back, but I found myself to be a bit more focused, and after I'd worked for the IEA, for instance, and maybe I certainly learned to present my work better. So everything around soft skill and being able to present your work, it's something which is certain that you learn more in the private sector than in academia, I think. Shortly.
All right, cool. Then there's a few more remarks. Again, from Paul said, I agree with Chris on stuff in the private sector. Also, there is a major trend for machine learning research in private labs, like Welling, Shovkov, LeCun, Bengio, Hinton. I don't know if I pronounced any of that correctly, anyway. But okay, it's good to know. Then Urban says, in academia, you don't have to actually come up with something practical and useful. As long as the idea is new, it can be published as a paper. And then Istvan has a question for Caroline, if time permits. If someone would say academic freedom has the word academic in it, it does not apply to the private sector. Your employer pays you, so you need to accept some things or move on. Of course, companies need to follow the law with regards to gender equality and others. What would your reaction be to that stance? It's related to the Timnit affair.
Sorry, give me a minute to think about it. I mean, I think in any companies you should be able to say, I don't agree with the way we work or the way you treat your people. I mean, it's not only a law; it's about being ethical, right? I mean, it's by principle, and I would quit a firm who wouldn't respect my opinion, even if we can disagree. But you have to be able to express it. I never had problems in academia, but I also never had problems in the private sector. So I don't know if university would be, I believe academic freedom also has its limits, but I never felt it, but I'm sure there's also people who work in academia who are restricted in what they can say and what they can do because of the opinion of the university. Maybe less so than in the private companies, because you always have that, you have to make money in the private sector. So that's a point that's maybe less true in academia. I don't answer you.
Well, I think that makes a lot of sense. Maybe with that, Frank, I'll add you back to the stream. I see you're still there, so here you go. Hi, Frank. You're still muted, by the way. But with that, I want to wrap up for tonight. Frank, thank you very much for your talk. Caroline, thank you very much as well. It was a pleasure. And thanks for all of you for joining. The next meetup is in January. I think Now, I'm not going to say a date because I'll be wrong. You'll see on meetup.com, you'll see new announcements soon. Somewhere in January, there will be our next meetup. Still virtual for now, but I'm looking forward to see all of you there. Thank you so much for the very interactive session today. I like the fact that there was a lot of discussion going on. I enjoyed that a lot. So, Frank, Caroline, I don't know if you have some last words to add to that.
No, thank you very much for
thank you for having. Very nice to be here. Meet you in person.
Yeah, one day. All right. Thank you all for being here. Take care. Bye.
Bye-bye.